Welcome back to part 2, the pressure vessel insert and cap. If you have a look at this sample geometry that I put together, again, it is not fully constrained, but it is going to allow us to come back and make some changes if we need to later. First, we're going to perform an offset, and I would like to offset towards the inside, this time only 1 millimeter. Okay? Now I am going to make some changes to this portion of the geometry at the top because I want to have a fillet relationship between these two objects right here of 0 millimeters. And also, I will not be needing these two small portions of the geometry. What I'm going to do instead is I'm going to close both sides of that outline so that that entire object acts as my profile for a revolve. So I will perform an additional revolve. This time I'm going to use the new shape that I created. My axis will be the exact same Z axis before. I don't want a new body, I want a new component. I would like to say okay to that. Remember, I checked the box to remember my size, but I also want to point out the fact that I was careful with my geometry to make this slightly smaller than the 20 millimeter opening. So this cap is only 19.6 millimeters. My radius is 9.8. At that point in time, I'm ready to create thread, and I would like to apply it to this surface right here, which will oppose the inside threads. And I did remember the size from the previous, and it is modeled, so I will say okay to that. Now, I would like to be able to insert my baking soda, so I will create one additional sketch here on that same plane, and I want to have a rectangle, and it is going to be a center rectangle. I would like to place that center point rectangle directly on this right here and drag it all the way out near the edge where I have about 1.5 to 2 millimeters excess hanging off, and I will then extrude that in both directions symmetrical. Okay, and the distance needs to be enough to cut all the way through both walls of the container. So that provides me with openings so that I can drop some baking soda down in here and charge my system. However, I still have this opening on the top so that if I tilted, it would spill the baking soda into the vinegar, but all of my pressure would immediately escape. What I want to be able to do is control for that, so I'm going to place an additional cylinder on top of my new cap, which I created, and snap directly to that intersection, make it 1 millimeter, and automatically join operation. Okay? So now that is completely closed off, assuming it's screwed down tight, and I need one last hole directly on top of this. Okay, and I want to make it exactly 5 millimeter for my diameter. I'm going to type 5 and enter. So that will be my pressure escape hole right there. I can eventually connect that to a valve in the next assignment. So let's have a look at what we've accomplished so far. Switch to the home view. We'll turn component 1 back on. We'll call this component 1 bottle. and we will call component 2 cap. All right, let's inspect, and from the inspect menu, perform a section analysis. We're going to use this plane right here, and we're going to view our progress to make sure that we see exactly what we intend to have connected. Yes, all of this material will interact with each other in a successful manner by tilting the bottle 90 degrees after it's screwed on. Then the baking soda and the vinegar would be able to interact with each other, and the pressure would escape through this valve right here. Don't forget to save your work. And again, if you intend to 3D print your work, please pay special attention to the minimum and maximum wall thickness values that I have mentioned.